Welcome back to HANA Basics for Developers. So now that we've deployed our application, you might think that we're finished, but I have a couple specialized topics that I want to cover as well. First one is unit testing. Now, I know this is not everyone's favorite topic, the idea of testing. Often I met a lot of application developers that feel like testing is someone else's job to do. Maybe you have dedicated um, testers, or maybe you feel it's the business's responsibility to test the applications. But in fact, what we're going to talk about today is unit testing, the kinds of tests that developers do on small blocks of code or individual development objects really should be done before you merge your code back to Git or before you deploy your application. Some people might refer to this as like sanity checks to make sure that when you make a change, you haven't broken something unintentionally. It isn't meant to be end-to-end application testing. It's really the kinds of tests that the developer should write, own, and execute as part of the development process. And what we're going to see here today is how we can both write unit tests for our complete application, but also run them from the SAP Web IDE. There we are. And what we have is we have our project that we've been working on all along. What I've actually done is switched to a slightly different version of the project. This is the finished version that's available as part out in GitHub as part of the Open SAP course. It's really what we've been doing the individual exercises and working towards this. But what I have in the finished example, and I'll just go out here to GitHub and show you. Particularly if you go to the master branch, we've been going to the snippets to get our little code snippets. But the master branch is really the sample solution, and it's got all the exercise solutions, but also a lot of additional things. Maybe some of the things that I haven't written exercises for, some other demos, some other content, and that's what we're really going to focus on now. Not things that I have individual exercises for, but some of this other content. And for instance, as we're going to see here in a minute, I've written unit tests in this sample implementation. Now, the other thing that I will show you here in my videos, so what I've done is, this is actually for some of the later videos, this won't be necessary for the first. You notice I'm working in a different branch. I'm not working in the master branch, I'm working in the next prep branch. It is out here already in Git if you want to see, but basically I've got a separate branch where I'm preparing content for the next release. Of course, we have a new release of HANA planned to come out in the April-May 2019 timeframe. So spring, for those of us in the Northern Hemisphere, spring 2019. And I've just started preparing some of the content for that. I do this in the open in Git, and I do it in a separate branch so as not to disrupt anybody that's like going through the current videos or things like that, but it lets me play around with some things that I'll show you specifically in later exercises. But that's the branch that I'm working in. I don't want to make any changes to the master branch now because people have started taking the Open SAP course. They've started going through this video series. I don't want to change anything else. So I'm going to change some things for these latter videos, and I'm going to do it in a separate branch, just so everybody knows what we're working with here. Now, if you were to clone this extra branch, this next prep branch, it probably wouldn't work in your system yet because I have put some things in here that are planned to come in the next release of HANA that I already have because I'm running an internal build of the next release of HANA. For instance, you might come here and look at the package.json and see that I'm actually running against Node version 10, which your system on SPS 03 wouldn't have yet, but when you upgrade, you would have it in the future once we make the next release. But that isn't going to throw off our unit test. You'll find the unit test in the master branch as well. Okay, so hopefully I haven't confused anyone. This discussion of branches and why I'm using different branches. Just a little background there. Hopefully to clear up if you notice some little difference there. All right. What we want to talk about, though, in this video is really unit test. I want to show you first the mechanism that we have to write and run unit tests, and then we'll look at some of the individual tests that I've written and how we can interact with the test results. Now, unit tests are the kind of thing that should be runnable in an automated manner or interactively. If I'm working here in the Web IDE and I want to run a battery test, say before I'm done with a project, I make a little change and I want to test, across the impact that it has across my whole application, I should be able to run it interactively here in the Web IDE. But it should also be the kind of thing that, in part of a continuous integration tool chain, every time that I push and do a build and maybe deploy to a particular environment, I should be able to run all these tests automated as well. So the infrastructure that we're using here is designed to work in either scenario, either interactively or in a automated fashion as part of a continuous integration tool chain. And what we've done, and you might have noticed the wizard generated a lot of this stuff for us when we created the modules initially. But if you look here in the package.json, we've been really focused on the start script. We've used this before to either initially start the CDS module directly. That was the way the wizard originally generated our start script. Or we've seen we changed it to point to server.js to be our bootstrap of our Node.js module. But you might have noticed there were these other two entries here for test and test coverage. So npm and node, when it starts, there are certain built-in actions that it understands, that it will read the package.json, and by default, if you don't tell it what kind of action to start the Node service as, it's going to go to the start script by default. But we can tell Node that we want to run test, and it will start our application with a different start script. And this is very useful to have. I mean, we could start normally with server.js, or like in the case of automated testing, we might just run this as a task and say start the module temporarily and run it as a test. And then we'll start it completely differently. In this case, instead of starting with our start script, it's going to start a open source module called gulp. And what you see here is we didn't write our own test framework. In the old XS.js, XS Classic environment, we had written XS Unit, where we'd actually taken some open source JavaScript libraries, Jasmine and Mockstar, and we had adapted them to work in the XS.js environment. Here we don't need to do that because we're using standard Node. We can use standard modules, so there's nothing delivered by SAP. There's nothing you have to go download to replace XS Unit. Here we're just using gulp and Jasmine as our test framework. And that means you can go out to the internet, you can do a Google search on gulp, on Jasmine, you can get examples of how to write unit test, you can read up on the test framework and how it works, and really all that documentation, it doesn't come from SAP, it comes from the community. But when we generate the project, we do generate the dev dependencies, meaning gulp and Jasmine. If you're just building the application, deploying to production, it's not going to pull these articles in. It's only going to be if you run a test or test coverage that it's going to pull these modules in. So we have nicely separated there. But it allows us to build our test. And what we do from the Web IDE when we want to access these is we can have multiple run configurations. So you can come into the run menu and you can say run configurations. And by default, we would have a start script that would just say start the package.json and use the script name start. But you can come here and you can add an additional run configuration, and you can tell it use the test one. And I've done that already. I've said use the test, and then what it's going to do, it's going to still start with the package.json, but you see then I can choose a different script from the package.json. In this case, I'm going to run the test script. So it's going to start gulp for me, and then I can add some arguments on here as well. We'll actually come back and talk about that in a minute. Let's just start with the basics first, and say I want to run this test. And then you would actually just save this, or I can just say, okay, I haven't made any changes to it. And you can run, instead of the normal start script, if I hit the run here, it's going to run the start script, but I could say, let's run the test script instead. So what it's going to do is it's going to restart the module, but this time it's going to run the test. And that's what we see it kicking off. It's executing gulp, which is starting jasmine, and it's actually running a battery of tests. And we'll give it a couple seconds here. I have quite a few tests in my application, so it does take a few seconds to run. And we see that it's finished. And what we can do now is we can actually open this test results panel in the Web IDE. And if we do a drop down, we can run multiple tests over time, and it will save the results here. I've only ran it once so far. So let's go ahead and choose this. And what we see is it took 18 seconds to run. There were 0 failures, and I didn't run with code coverage, so it didn't do a coverage analysis of how much of the code was covered by the test. But I could do that. I could run a test coverage as well. But what we see here, that's what I want to see. I want to see 0 failures. And we see each individual test. And I have, as I said, quite a few of them in my application. We'll go through some of the different types of tests and how I wrote these in a second. But I use this. I mean, it's a good sample of how to use testing, but also I found it's been very useful for me just to have all these tests as part of the project, because when I do make a change, I can very quickly test all different kinds and parts of my application. You see that I'm testing some of the RESTful services, I'm testing the OData services, the CDS services, the OData v4 services, I'm testing my XSJS RESTful services, I'm also testing even my database artifacts. I'm making sure that all my tables are still there, that they have data in them. I'm able to test my stored procedures. I can call the stored procedures and look for certain results, make sure that they're still giving me the right results. And you see, you know, in a matter of a couple seconds, I can mass test my entire project. So it's quite a powerful thing, and it's worth investing in the test scripts. You know, every time I add a new part, it does mean I have to go add a new test script, but it's well worth it because of the benefits that it provides me here. Now let's look at the test script. So when you run gulp, it's going to look for a folder called tests, and this was generated by the wizard. It generated just the sample spec.js, which gives me a little example of what a test script looks like. Basically, each of these, and let's pull the test back up here so you can see this. Each of these little descriptions here, like what test is being performed, like spec script, or here it is, test sample spec. I'm just taking the current file name, __ file name, and that's getting put out in the test with the describe command. And then I have an individual test inside here. So that's this first test. So that's first test. The description is coming from whatever you put in the test description. We can have multiple tests per block here. And this is very simple. Expect true to be true, which of course that's going to pass because we're just taking the built-in value true and making sure that it's equal to true, and then we tell it that we're done with our test. Okay, that lets the test framework know we're finished. If we have some asynchronous operations, obviously we're testing Node.js, we might call this done inside the callback handler, and all this is done asynchronously as well. These tests aren't executing sequentially, I might be testing a RESTful call at the same time that I'm testing a database call. That's fine. It's all going to be parallelized by the test framework, but that's why we have to call this done, the callback, to let the overall gulp framework know that this individual test is done. Okay, that's a really simple one. Let's look at something maybe a little bit more complex, like calling a database procedure. So here we want to test the applied discount database procedure. Well, what we're going to want to do is obviously get a connection to the database. Now we're not going through the bootstrap So we're not going through server.js. Each test is going to start up, and it's going to need its own connection to the database. Individually, we want to test the connection to the database as well. So what I've done here is I've just taken a little test utility script. So that's what I've added to my utilities. I've created this test.js. What I've done is I pulled out some of the parts of the bootstrap that we had. Specifically, like in the case of getting the database client, we're not going to have Express to pass in our already established database connection. So what we're going to need is we're going to need to be able to get our own database connection. Now we still have our binding, so I can still use the XS environment to get a connection to the container, the HDI resource, and then I can use that to initialize the HDB ext module and create a connection to the database, and then simply return that database connection. So I'm going to do this over and over again in each of my test scripts. I don't want to put all this code in each test script, and then the same thing here to get our database class. We want to reuse the little promises wrapper around the HDB ext. So what we're able to do here is I want to go back to this DB promises JS. That's where I wrote the wrapper around HDB ext, just to expose it as with promises, so we can use async await on it and make the code really nice and clean. I just have another little helper here that will also establish those calls and deal with the promises and things like that. It keeps my test script really lean, because what you see here in my test script, what I can have is I can have multiple tests, and I can have a before each. So that's like a little startup block of code. Now in this case, I only have one test. I'll show you some other examples here where I have multiple tests. But if I have multiple, then what it's going to do for each test, it's going to establish a connection to the database. And that's what I've done here, is just to store my database class object. I'm putting it into the this for the test. And I'm able to do that. I'm able to get my database client and then send that into the initialization of the database class. So then inside each test, what I have is I can just write simple select statements. So for instance, prepare a promise-fied statement, and here's the select against my function, and then execute it. And then I'll get my results back, and I can write gulp test against the results. For instance, I'm going to say that the length of results should not be less than 1, so I should get at least 1 record back. And then I know inside there I've got a structure with ex results. Should not be less than 180. I should get 180 records back. And actually, no, I should get exactly 180 records in this case. The value for this, the export results should be 180, so I'm testing that it's not less than and not greater than 180. Okay, and then if I pass, then I'm going to get the green check mark. Let's look at maybe one of these others. All the functions are pretty much the same. Let's maybe look at a stored procedure one. So addresses from employees, same sort of thing, except here we'll get the get stored procedure wrapper, and then we can call the stored procedure. Here we're just checking that the value, we get 33 records back between 2 integers. So here what we see is we're going to call the stored procedure between 2 integers. We're actually going to run 2 tests on it, a true and a false check. So here we're going to pass in 5 and 3 and 9. So 5 is between 3 and 9. So the value that we get back should be true. Now we want to send in a false. So we're going to say pass in 1 and say 1 should be between 3 and 9, which obviously it's not. So we should get a false value back. So we can test multiple conditions. We can, like in this case, we're calling the same stored procedure multiple times with different input values. We only need to write our initialization code once. It's going to be executed before each of these tests, and then we can test for different results. So that's you know, the rest of these database level checks are pretty much the same. For my tables and views, I can test all of those as well. So I just wrote a generic view test, and here what I'm doing is I'm basically just building up an array of all the views in my application that I want to test, and then I wrote a real generic test. I'm going to say for each element that's in this array, perform the test. So it's going to actually do a whole bunch of tests, but I don't need to write them individually. I'm just going to very generically here say select star from whatever the view name is, and then I'm going to check to make sure I got at least one record back from the view. And this is mainly to make sure that over time that my views don't break. You know, if I would make a change and it would somehow invalidate one of these views, or I accidentally rename a view or something like that, then I want to check it to catch it here in my unit test, because if I do a select against it and I don't get at least one row back, then I know that something's wrong with one of my views, and I can catch it right away. Same thing here with the tables. Just building up an array of the tables, and I'm going to do the same thing, select from the table, and make sure that I get at least one row back. And that makes sure I didn't do something like change a table name once again that would throw off my logic. Okay. Now we're getting into, you know, that's our database checks, but now let's talk about how we can check our XSJS, Node.js services, or RESTful services, our OData services. This is pretty straightforward, but the main thing that we're going to have to do here is we're not going to have Express, and we're not going to pass through the web module. We're going to be calling the service module directly. So what I did is I just wrote a little utility in my test utilities script here. So if we come back to utils test, you see this get express. So if I come down here to get express, what I'm doing is this is largely the same code from my server.js bootstrap, but I wanted to make a few changes to it. You know, I'm going to do the same thing. I'm going to load up Express. I'm going to load the CDS module. I'm going to establish my connection to the database. But I'm not passing through the web module, so I'm not going to have the security token. So what I did is I put a parameter on this to say whether it's going to be a secure test, and the default value is false. So most of these tests, I don't need the security. So what I'm going to do is I'm going to set the parameter here to say that it's okay that if I get an unauthorized request, and actually when I initialize my Express, if I'm not secure, then I'm going to go ahead and not give it the passport. So it's not going to validate whether I've got the JUT token. So I won't have a security token, but I will. So I'm not going to have the security token injected in the database, but it's good enough to do most of my testing. And what you'll see here is like, for instance, the node spec test. I'm getting my instance of Express, and then what we have is built into the gulp testing is this request object, and make an HTTP request. So from our test, we're going to make an HTTP request. We're going to come back to our same service here, so we're going to give it a relative URL, and it's going to do this, and we're passing in this app. It's going to use Express, the little instance of Express that we're going to create here inside each test frame. And then, of course, then we can do the same sort of expects, except against a, when we were doing it against the database, we're getting a result object back. We were getting some JSON back with a result object. Here we can test for things like expect 200. Well, that's going to be the status code. So expect a good status return. Expect content type, I can test for the content type that I'm going to get back. Some of these are just very basic. I just want to make sure that I get the right content type, that I'm not getting an error status code. Others are going to be a bit more sophisticated. Let me find another one here. No, we're going to come back to that one. Maybe the text bundle test. I'm going to test for the actual text that's coming back. I'm going to look at the response object. We can say expect res. That's going to give us the raw response object. And in this case, I'm going to say response text and get like the first block of text and say, does it have this text or does it have this text? So here I'm testing my text bundles. I'm able, just like we did from the browser, to change our language settings, except now I'm going to pass it in as a header parameter. So the accept language, so English, German, Japanese, and then I'm just going to check for the different text to make sure I'm getting my translated text back as well. I don't need to go to the web browser to test these scenarios. I could run this automated now. But maybe we have some tests that we want to run that we need security for, okay? And that's also a possibility here. But we're not passing through the app router. It's not generating the security token for us. But that's okay. When you make a call from node to node, which is what we want to do here between two microservices, you don't necessarily have to pass through the application router. You can write your own code to call to the UAA and get the authorization token. And that's actually what we're going to do here. Now what I did, and this is maybe not the best thing to do here, I'm actually going to pass the username and password for the authentication in as parameters on the test configuration. Now that's not horrible. If you remember here, I came here and I did my run configurations, and when I set up my test script, I actually added a parameter here for my username and my password. Now obviously this isn't being stored securely. This is my private system running on my local laptop. I'm using a generic user for demonstration purposes here. So I'm not that concerned about securing the password. The test configuration is actually stored in my local workspace. Yes, someone could go to the file system and see my password, so this probably isn't something you'd want to do. I'm using it for simple purposes here, passing in via the command line. You probably, if you really wanted to be secure, probably store this in the secure store and look it up dynamically. I'll admit, not the best way to do it, but still better than like hard coding it in the test script. But it does show you how you could get parameters from the test configuration, even if it's not username and password. They all come in as process ARGV, argument variables, and basically we're just pulling them out. But to make a request against the UAA, what we're basically going to want to do is make an HTTP request. So that's what we're doing here. I'm going to make a request against the UAA. The OAuth token, and the overall URL is actually for the UAA service is actually contained in the XS UAA configuration. So we can get the XS UAA configuration. Here I'm getting it directly from the VICAP. I could also read it using the XS environment, but that's going to give me like my client ID and my client secret, which I'm going to need to pack into the header. So you see why it's nice that the app router does all this for us. We would have to do this in code in each of our services to look up the UAA configuration, call over to the UAA. We'd have to somehow prompt the user for the username and password. The app router does that for us. But you see in these scripted scenarios, we can be done. It's a little tricky. We have to understand the headers and things like that. But basically, I'm building the request header. I'm putting the authorization in the authorization object. This is not that different than, say, what we had to do when we used Postman to do our testing as well. We're working with the lower level OAuth authentication, but we're just doing it here automated in our code. And you see inside the body of the request to the OAuth, to the UAA to get the security token, and we have to pass in the username and password in the body and our client ID and a client secret. Of course, we could use certificates here as well if we wanted to get really sophisticated and not pass the username and password even in the post request. But when we get it back, we're going to get a body back, and the body is going to contain JSON with our access token. And that's really what we need. We just need this access token. And then this access token can be passed into subsequent requests, and then they're going to be authorized requests. So when it comes to writing our test script, it doesn't have to be that complicated. When we initialize express, we just pass in true to tell it that we want a secure connection. And then when we make our request, we just need to add the authorization bearer header, and we can use the reusable little utility I wrote here to get auth token. So that's going to retrieve the auth token each time, write it into the header. The rest of the test script is no different. We're going to make the request like to the who am I that's going to read the security token and parse it, and then we're going to get, we're going to expect a 200 back. We're going to expect the body length not to be less than 1. So we're not doing real sophisticated tests here. Here we are checking for the name also in the user info. We don't know what our name coming back is going to be. We just want to make sure that we get something back, that the string for that is not less than 1. So that assures that we are getting authenticated and we're getting information back. Okay, so hopefully I've shown you how to use unit test, both from the Web IDE environment, using the run configurations, showing you a little bit about how to write unit test. Hopefully just made you aware that they're there and some of the value of having unit tests. And of course, you're welcome to come study the test scripts and the little test helper that I've provided if you want to look at how you could maybe build some of your own tests. But the main takeaway here is hopefully just made people aware. I find a lot of people that aren't even aware that we have the unit testing capabilities, mainly because we use a lot of open source libraries. So of course there isn't a lot of documentation in the SAP help, but make you aware that this is there, it's full featured, it's integrated in the Web IDE, and it's very powerful and very beneficial to the developer to create such tests.